So today we are going to do some of the trig products. So of the type sine the power mx cosine the power n x dx. We are doing first the case where one of these two have odd power. Okay, odd power. So now you notice in this one sine has odd power. So whichever has odd power, you're going to peel one of the trig functions. So basically what I'm trying to say here, this sine cube would be written as sine square x times sine x. We can do that, right? Sine x times sine square is sine cube. We're going to continue writing cosine square x dx. Okay. Now we peeled one sine off. The remaining all sines will be converted using to cosines using the formula. We know that 1 minus cosine square x is equal to sine square x. So the remaining sines can be replaced by what? 1 minus cosine square x. And there is cosine square x. And we have sine x dx, which we peeled away from the odd sine power. Now, we are going to use u sub technique to solve this remaining portion, and you will see how simple it becomes once you do that. I'm going to put u as cosine x function. And we know when you do substitution like that, we need to differentiate. That would be negative sine x dx. And you guys notice that we have sine x dx in the question, and that we manipulated, right? So that means sine x dx should be equal to negative du. When I make this all substitution, this will be 1 minus u square, because cosine I put as u. This is also u square. And this sine x dx is negative du. Negative, I take it outside. Okay, negative. This u square can distribute inside. This will become u square minus u4 with respect to u. And now this is a very simple integral using the power rule. If you remember, our power formula is integral x to the power n, add the power, divide by the new power. So we can use that here. U to the power 3 by 3 minus u to the power 4 plus 1, 5 by 5. There is negative outside plus c. U is cosine, so you need to always put it back. Cosine cube x by 3 minus cosine 5x by 5. Take care of the parenthesis, because when the parenthesis goes inside, this is going to become positive. This is your final answer. So this is the case when one of the power either of sine or cosine is odd. Okay. Let's do another example of odd powers. In this question, sine cube is here. Cosine's power is half because it's into the square root. We are going to use a similar technique which we just learned. From the odd power of sine, we're going to kind of peel one sine away. Peeling it away means that you need to split it as sine square theta times sine theta. Okay. As we wrote the formula, 1 minus cosine square theta can be replaced in place of sine square theta. So this would be square root of cosine theta. This sine square theta can be replaced by 1 minus cosine square theta times sine theta d theta. When you have here, you're going to use u sub technique and put u as cosine theta. Differentiating that would be du negative sine theta d theta. We have sine theta d theta in the question. So sine theta d theta will become negative du. Let's try to substitute it all. Square root of cosine theta is u. 1 minus cosine theta is u square. This thing becomes negative u du. I put negative outside. Okay. So you see, this becomes simpler if we distribute this inside. This will be negative root u minus u square. Let's write it down on the side. U square times root u. U square times u the power half. Powers add, so 2 plus half. That would be u the power 5 by 2. So this basically is u the power 5 by 2 du. And I'm going to replace this also. This can be written as u the power half because root u is u the power half. Now we can apply the power formula. U the power half plus 1, 3 by 2 by 3 by 2 minus 5 by 2 plus 1 is 7 by 2 by 7 by 2. That is the integral using the power rule. We can erase that. And this thing would be equal to minus. This 3 by 2 flips and comes here. And we need to put u back as in cosine theta. Cosine power 3 by 2 minus 2 by 7 cosine 7 by 2 theta plus c. And at the end you can adjust negative inside. There's nothing in the denominator. Plus c. I wanted to do one more example of this kind when we have the multiple of sines and cosine powers, but one of them is odd power. But notice in this one, cosine's power is odd here. So whichever is power is odd, you're gonna peel cosine now because cosine's power is odd. So peeling means writing it cosine square x times cosine x. So I'm not really changing anything. Cosine cube can be written as cosine square times cosine. Now, cosine square x can be replaced as 1 minus sine square x. So you should remember that this all is coming from the same identity, that sine square x plus cosine square x is equal to 1. So from there we can say cosine square x is equal to 1 minus sine square x. So let's try. Sine square x is here. Cosine square x would become 1 minus sine square x times cosine x dx. Once we have that, like everything is in terms of sine, but there's cosine x dx, we can use u sub technique to put u equal to sine of x. Differentiating du will be cosine x dx. So that's already sitting in the question. So we can replace now. Sine is u square 1 minus u square, and this whole thing can be replaced as du. This u square can distribute inside. So u square times 1 u square minus u square times u square would be u4 du. We can integrate it using the power rule. This will become u the cube by 3 minus u the power 5 by 5 plus c, and u has to be substituted back to sine x. Sine cube x by 3 minus sine 5x by 5 plus c.